Hey guys, make sure you're watching the correct video. This is 2 for day 2. And get ready. This is going to be a tough video. This is going to be a tough lesson. It's combining the chain rule with the product and the quotient rule. In fact, today and tomorrow we're going to be doing the exact same thing. I'm not going to teach you anything new. Tomorrow on the video we're just going to do more practice problems because it's going to take about 2 days for this stuff to sink in. So just hang in there with me today, and we're going to practice this today and tomorrow as well. Okay, let's get to the first example. It says, example 1, find all points on the graph of f of x equals the cube root of x squared minus 1 quantity squared, for which the derivative equals 0 and for which the derivative does not exist. So first and foremost, what do we have to do but find that derivative? I'm going to go ahead and rewrite this as f of x equals x squared minus 1 raised to the 2/3. That's the first thing I'm going to do. That's a 2 and that's a 3. And then I'm going to use my chain rule where u is equal to x squared minus 1, u prime is equal to 2x, and then I'm going to use the general power rule to go ahead and differentiate x squared minus 1 to the 2/3. Remember, the general power rule is just n times u to the n minus 1 times u prime. So I'm going to use that a lot in this lesson. It's just the general power rule. It's basically the chain rule also with the general power rule applied to it. Okay, so using the general power rule, I've said that enough now, we've got f prime of x would be equal to n, which is 2/3, times u to the 2/3 minus 1, which is negative 1/3, times u prime, which, be very careful here. Notice that that's not u to the first, it's u prime. So be very careful that you keep track of that. Now what I'm going to do is take out all my u's and u primes and substitute them with what I have up here. So I get f prime of x equals 2/3. I'm going to go ahead and write the u below, which is x squared minus 1 raised to the 1/3 times what u prime is, which is 2x. And that's over 1. I'm going to multiply across the top, so I finally get f prime of x equals 4x on top, all over 3 parentheses x squared minus 1 raised to the 1/3. Now here's the actual question. This is what it wants to know. It wants to know what is the derivative, or what points where the derivative equals 0, and at what points does the derivative not exist. Well, if we think about this, when we want to set it equal to 0, that's finding that horizontal tangent. What have I said over and over again when it comes to an actual quotient? All we care about is the numerator. So to determine f prime of x equals 0, I'm going to take the numerator, set it equal to 0, and I get x equals 0. If I take 0, plug it back into the original equation, I get f of 0 equal to 0. So the point at which it equals 0, or horizontal slope, is 0, 0. Now the next part is new. They want to know, where does f prime of x not exist? And where do we know things don't exist is in the denominator. So we're going to take the denominator and we're going to set it equal to 0 also. So 3 parentheses x squared minus 1 raised to the 1/3 equals 0. I can divide by 3, and that's going to give me 0. So I get x squared minus 1 raised to the 1/3 equals 0. I can raise both sides to the power of 3, and that gets rid of my exponent over there, so I have x squared minus 1 equals 0, and here I'm going to get x equals plus or minus 1. So find all points for at which the graph does not exist. It would not exist at x equals 1 and x equals negative 1. And for which points that f of x equals 0, that would be 0, 0. So if you actually graphed this out on your graphing calculator, because I can't do this in my head, you would have a straight line coming down to -1 and a curve, and then a straight line going back up. So looking at what we just found, here at -1 and +1, you have a sharp turn. And remember what we talked about, derivatives do not exist at sharp turns. And then at x equals 0, there's x equals 0, we have a horizontal slope. So all those things we could find just by looking at the graph also. All right, so that's the easy of the examples today. So hopefully that wasn't too bad. And let's go ahead and let's hurt our brains a little bit. Okay, so we're going to combine the chain rule with the product and the quotient rule. All right, so first things first, I'm going to do exactly what I did before. I'm going to set my inner function equal to u, and then I'm going to do the derivative of u. So here, our inner function again is still inside of here. So u equals 3x minus 1 over x squared plus 3. To find the derivative of this, we need to use the quotient rule, which if you remember the quotient rule was low d high minus high d low over low squared. So let's go ahead and find d high, the derivative of the high one, which is 3. The derivative of the low is 2x, and let's go ahead and combine all that into our derivative over here. So we end up with the low x squared plus 3, derivative of the high is 3, minus the high, which is 3x minus 1, times the derivative of the low, which is 2x. All over low squared, which is x squared plus 3 quantity squared. All right, let's go ahead and clean this up. Distribute your 3 into here, distribute your 2x into here. And that would leave me with 3x squared plus 9 minus, again, I haven't distributed that negative yet, so just hold off on that negative, 6x squared minus 2x, all over x squared plus 3 quantity squared. Okay, now what I'm going to do, I'm going to distribute that negative into the parentheses. And I get 3x squared plus 9 minus 6x squared plus 2x. All over x squared plus 3 quantity squared. I'm going to go ahead and clean this up just a little bit more. And I get negative 3x squared plus 2x plus 9 all over x squared plus 3 squared. So that's the first step, going in and finding u and then finding the derivative of u. Now looking at y equals u squared, I'm going to again use, if I just write this as y equals u squared, I'm going to do the derivative and I'm going to use the general power rule. So y prime would equal 2 times u to the 1 times u prime. I make it actually look like a 1 so you know the difference between u prime and u to the first. So now I'm just going to substitute everything back in, take out my u's, and plug in with what actual the function is. So I get y prime equals 2 parentheses 3x minus 1 over x squared plus 3 parentheses closed times the derivative of u, which is all this massive craziness right there, negative 3x squared plus 2x plus 9 all over x squared plus 3 quantity squared. And then what we're going to do is just basically combine this all into one function. Leave the numerator as the parentheses of 2 and then 3x minus 1 and then this numerator. Leave all that factored because that's how they like to see it. So our final answer is y prime. We've got 2 on the very outside, 3x minus 1, and then negative 3x squared plus 2x plus 9. And all of that is over. If you look, we've got another one here and one here, so we would do to the first plus 2. We add our exponents whenever we multiply. And that is our answer. That right there. So good job if you were able to hang with me on that one. That one was a little difficult. All right, let's do another one. Okay, this one's going to be a little bit more challenging because it's going to have a trick in it where we're going to factor out a very nasty looking factor, but as soon as you get comfortable with it, we're going to do that quite a bit throughout the whole entire lesson whenever you have this radical. So it's going to come up again and again and again. You might as well just get used to it, and the more you practice it, the better it's going to get. Okay, so again, starting off with, I'm going to have to do the product rule because I see that I've got two functions here, but within that product rule, I'm going to have to do the chain rule for that one. So the very first thing I am going to do is actually rewrite this whole entire problem. So let's rewrite x squared times 1 minus x squared raised to the 1/2. Okay, now I need to go, and since I am doing the product rule, I need to find, this is LDF plus FDL. So the last, I need to do the derivative of the first, which is 2x, and the derivative of the last is going to be where that general power rule comes into play. So I'm doing the derivative of this part right now. I set u equal to 1 minus x squared. U prime would be negative 2x, and then if I did the derivative of L, it would be 1/2 times u to the negative 1/2 times u prime. That's just the general power rule. Remember, I just keep doing that over and over again. Now what I'm going to do is I'm going to substitute in what my u's actually were. So wherever u is, that's going to go 1 minus x squared. Wherever u prime is going to go negative 2x. So my derivative of my last actually ends up being 1/2. And this time, don't write the negative exponent below. Keep it on the top because you're going to see we're going to actually factor out in a few minutes this negative exponent, and it makes it easier for you to see if it's on top. And then times negative 2x. Now, if you look, sometimes some canceling can go here. I've got a 2 on the bottom and a negative 2 on the top. So those 2's are going to cancel, and I'm left with negative x parentheses 1 minus x squared to the negative 1/2. All that work and all I found was the derivative of the last. Okay, now what I'm going to go and do is actually LDF plus FDL. Break this up a little bit. Okay, LDF plus FDL. So I need my last function. So the derivative of f of x, or f prime of x, is equal to the last function, which is 1 minus x squared to the 1/2, times the derivative of the first, which is 2x, plus the first function, which is x squared, times the derivative of the last, which is negative x 1 minus x squared to the negative 1/2. Okay, this is where that little trick is going to come into play. Well, first let me go through and clean it up. Let me multiply those terms right there. All right, so real fast, f prime of x equals, equals 2x parentheses 1 minus x squared to the 1/2 minus x cubed 1 minus x squared to the negative 1/2. Okay, as we can see, we have 1 minus x squared here and 1 minus x squared there. We can factor out a 1 minus x squared, and what we're going to factor out is the more challenging one, which is the negative exponent. So you're going to see when I factor it out, he's going to sit on the outside. So at this step, factor out 1 minus x squared to the negative 1/2. And think about when you're factoring something out, you're dividing it. And whenever we divide something, we subtract the exponents. So that's what I'm going to be doing right now. I'm going to go in and I'm going to subtract the exponents. Also, I can pull out an x. I just now saw that. So I'm going to attach a little x on the outside, which hopefully doesn't throw things off for you guys. Okay, so work with me. We've got the derivative of f, and I'm pulling all this part out. So I have x on the outside, 1 minus x squared to the negative 1/2. And then I'm going to put brackets here. So this x went out. He's gone. So I'm just left with 2. Parentheses, 1 minus x squared raised to the 1/2, and this is what I said I'm going to do. I'm going to subtract what I pulled out because I'm dividing it. If you go over to the side for a little bit, I'm basically doing 1 minus x squared to the 1/2 divided by 1 minus x squared to the negative 1/2. What do we do to our exponents when we're dividing? We subtract. So that's what I'm going to do right here. Minus negative 1/2. You're going to see something happen, and it happens every single time we do this. Okay, then we have minus x cubed. I factor out an x, so I'm left with x squared. And then parentheses, 1 minus x squared to the negative 1/2 minus negative 1/2. Okay, let's go in and clean this up. First and foremost, we still have our x sitting in the front with 1 minus x squared. They're just waiting patiently for you to figure out all this mumbo jumbo in here. Okay, look up here. What is 1/2 plus 1/2? That's going to equal 1. So that whole entire nasty exponent actually turns to just 2 times 1 minus x squared. And then we've got minus x squared. Look at all of this. We've got negative 1/2 minus a negative 1/2. That turns to negative 1/2 plus 1/2, which ends up being 0. So all of this raised to 0 equals just 1. So that's just times 1, which doesn't do anything to the problem. So all of that goes away, which is nice because I'm left with this simplified version of what I had before. So going in and cleaning it up again a little bit more, what I'm going to do now, I'm distribute him in there. So I get 2 minus 2x squared minus x squared, and that becomes 2 minus 3x squared. Last, all you have to do is just combine this a little bit more, and I'm going to have the final answer. This is going to stay in the numerator, this is in the numerator, so x times 2 minus 3x squared all over 1 minus x squared raised to the 1/2. Whew! That was challenging. That was 8 minutes in and of itself. So looking back at the very beginning of it all, rewriting it, raising it to the 1/2, going and doing what we did all before with just this right here, finding the derivative of the first, derivative of the last, using our general power rule. And then when we went over here, we had to factor out factor out 1 minus x squared to the negative 1/2. This is going to happen every time, just so you know. Every time we do this, one of the factors is going to turn to the power of 0, which makes it go to 1. The other one is going to turn to 1. So the more you practice this, the easier it's going to get. Okay, let's go ahead and go to the next slide. Okay, what I want you to do, because I feel like we're already kind of fried out right now, this was actually originally an example 4. I want you just to go ahead and try this as a U try. So do a U try for this one, and hopefully we can get it right. The first thing I would do, though, is rewrite this before you actually go and try it. Rewrite it, because if you rewrite it, it becomes similar to the last one. X times x squared plus 4 raised to the 1/3. Negative 1/3. Alright guys, so go ahead and pause the video, try this on your own, see if you can get the same answer as me. I know your head probably hurts, just work through this one, use my same steps as the last one, hopefully we can get the same answer. Okay guys, here's your final answer. It's way down here. X squared plus 12 over 3 parentheses x squared plus 4 raised to the 2/3. And I know your head's probably hurting right now, so we're just going to go ahead and wrap up this lesson, and we'll definitely practice all day tomorrow in class. We're just going to be doing 7 through 29 odd. It's just practice, practice, practice over and over again. If you have any questions, make sure you're writing them down, and I will help you with those questions tomorrow in class. All right, good luck, or good job for sticking in there, guys. I know this was a hard one. I'm proud of you. See you tomorrow in class.